So hello everyone. So in this video I'll discuss the differentiator circuit using op-amp and the ideal differentiator circuit. So this is the inverting op-amp and just replacing this resistor R1 with a capacitor and we'll get the circuit that the ideal differentiator. So this is just a way of relating the two circuits because this is the mere difference between these two circuits, and just as I have related the inverting op-amp and ideal integrator also. So this is the ideal differentiator. So it means output should be proportional to the derivative of input, right? And this is the ideal op-amp. So virtual one concept is valid here. So whatever current is flowing in this capacitor, which is the capacitor current, is directly flowing in this resistor also. So this capacitor current is equals to minus of V0 by RF, right? And which is equals to C dVc by dt. And this Vc, as we can clearly see, this Vc is equals to Vin. So it will be dVin by dt. So from here, the V0 will be equals to minus RFC and dVin by dt. Right. So this is the output of ideal differentiator. And here also we can see this negative sign showing that the phase is 180 degree, right? Now the transfer function of this ideal differentiator. So for getting the transfer function, we will apply a KCL, get this inverting terminal. So KCL will be Vn minus 0 by 1 upon Cs equals to 0 minus of V0 divided by Rf. So V0 by Vn, which is the transfer function, is equals to minus Rf Ps. This is the transfer function. And we can clearly see that there is a 1 0 at origin, so the pole 0 plot will be simply 0 at origin. So that is the pole 0 plot of this ideal differentiator. Now for the frequency response, we will put the S is equal to j omega and the transform function to t of j omega will be minus r of c and j omega. The magnitude will be simply RFC of omega. You can see that it is directly proportional to omega. So the magnitude at zero frequency will be 0, and at infinite frequency the magnitude is infinite. So at infinite frequency the magnitude is tending towards infinite, so this is known as the high frequency instability or high frequency roll off, which is the drawback of this ideal differentiator circuit. We can draw the magnitude plot here. It's simply linearly increasing with the frequency, right? So this is the magnitude plot. The slope of RFC, and it will be tending towards infinite at infinite frequency, and this is nothing but the high frequency roll off, which is the drawback of this ideal differentiator circuit. So for avoiding this drawback or the problem of this high frequency roll off, we use the practical differentiator circuit, which I'll discuss in the next video. So now let's have a look on the different for the different inputs. What is the output of this ideal differentiator? So this is the ideal differentiator circuit, and just I'm letting this values as 1 ohm and 1 farad, which means the output for any value of for any input will be simply minus of dvi by dt, right? So if the input is a unit step input, this, so this is the input unit step. So output will be simply for this output will be simply a negative impulse at origin. So this will be the output for this input. Now if the input is the pulse form, this is the pulse. For this input, the output will be impulse train, right? So जैसे यहाँ पर we can let the values 1 volt, this is the -1, t by 2 t and so on. So output will be like this. First there will be impulse of, यहाँ पर बेसिकली दिस विल बी -1 के एरिया का, बट उसके बाद फिर ये टू एरिया विल बी 2 और फिर ये सिंपली रिपीट करता रहेगा इस तरह से। यहाँ पर भी दिस विल बी -2 देन अगेन विल बी +2 एंड सो ऑन। तो ये बेसिकली इम्पल्स चेंज जाएगी, राइट। इसका एक्सप्रेशन भी वी कैन राइट अगेन सेम जैसा यहाँ पर इसका जो एक्सप्रेशन होगा बेसिकली इस तरह से होगा, माइनस डेल्टा टी देन विल बी +2 del of this will be t by 2, this is t 3 t by 1 so on, 2 del of t minus of t by 2 then again -2 del t minus of t and so on, right. Now if the input is a ramp input, I'm taking this one, this input is तरह का ramp input है, so this is the input and it is repeating again, just letting this value is 1 volt, then this is t by 2, this is t, then this is t by 2. So the slope will be the height of the this, because the output will be a unit step, right, like this। basically इसका inverted version मिलेगा, so output will be minus of dvn by dt। so यहाँ पर output will be like this, यहाँ से ऐसा, then this one, and this height will be the equal to the slope of the ramp, and it is repeating। so this will be, slope will be 2 by t, so it will be minus of 2 by t, and this will be plus 2 by t, and this repeating। so this is how we can draw the output for the input at the inverting, oh sorry, the ideal differentiator। So this was the discussion of ideal differentiator circuit, so okay, thank you।